Section 7.6 talks about exponential and logarithmic equations and how we're going to solve them. So what's an exponential equation? It's an equation that contains variables in the exponents. Nothing new. We've been using these since the beginning of the chapter. So the property of equality for exponential equations says that if two powers of the same base are equal, then their exponents are equal. If two exponents are equal, then their powers with the same base are equal. So with that, symbolically, what that says is if this statement right here. If I have b to the x equal b to the y, that is true if and only if x equals y. So just as a mini example here, 3 to the 7 is equal to 3 to the y if and only if, that's IFF, 7 equals y. And that's true, like these are only going to be equal if y equals 7. That sort of should make sense intuitively. So our goal here is to get the bases to be the same. So here let's look at example 1. Solve the exponential equation below using a common base. So I like to think of example 1 here, 25 to the 3x equals 125 to the x minus, or to the x plus 2. So I like to think, how could I break up 25? I can only use 5 to break it up, right? So 5 squared is 25, right? How could I do that? How could I do the same thing with 25? I want the base to be the same. If I want the base to be the same, I would try to use 5. Could I raise 5 to some power and get 125? And the answer there is yes. I could raise it to the third power now to get 125. So it looks like I could use a base of 5 here. A lot of this is going to require you just to inspect and compare your two original bases. So here I could use a base of 5. So 25 is 5 to the power of 2 to the 3x. And 125 is 5 to the power of 3. This is raised to the x plus 2. So I can rewrite this. I would multiply 2 times 3x. So this is 5 to the 6x equals 5 to the 3 times x plus 2. So my bases are the same, and now I can use this property of equality that says if my bases are the same, b to the x equals b to the y if and only if x equals y. So 5 to the 6x is equal to 5 to the 3x plus 2 if and only if 6x equals 3 times x plus 2. And now I can solve this and figure out what x is. So 6x equals, distribute the 3x plus 6. I'm going to do the rest of the work up over here. So 6x equals 3x plus 6. Subtract 3x from both sides. So this is 3x equals 6. Divide both sides by 3. So x is 2. And you could double check this by plugging 2 into your original equation. And you would see that both of these are equal to each other. So as long as your bases are the same, you can use this property of equality for exponents. So for example 2 here, it says rewrite the exponential equation using logarithms. 17 equals 4 to the x. There's no way I could rewrite 17. 17 is a prime number. There's no number I can multiply together to get, no two whole numbers I can multiply together to get 17. So there's no way I'm going to be able to break down 17. So what I'm going to do is I'm going to take log base 4 of 17 and set that equal to log base 4 of 4 to the x. Because my base was 4. So these 4's go away, and I'm left with x. So this is log base 4 of 17 equals x. I can simplify this using what we did in the last section, the change of base. So this would be, m would be 17 and your b would be 4. Sorry, your n would be 4. So this would be log of 17 divided by log of 4, and that would get you your x. But it's nice a little recap of what we did in the previous section. So I did that one to show you this one. A logarithmic equation contains one or more logarithms of variables. So we get this property of equality for logarithmic equations, just like we had one for exponential equations. This says that if two logarithms of the same base are equal, then the quantities are equal. If two quantities are equal, then the bases are the same, then the logarithms are equal. So that's a whole lot of terminology there. Let's break it down just and give you this symbolically or algebraically. So it says suppose x is bigger than 0, then you have log base b of x equals log base b of y if and only if x equals y. So as an example for that one, let's say we have log base 3 of x equal to log base 3 of 4. Well, this is true if and only if x equals 4. And again, this shouldn't make sense intuitively, like if these are going to be equal, then x should be 4. Just like the last property, if these are going to be the same, then x should equal 4. Again, this should be more intuition than anything. Example 3, they want to know what is the solution to 3 to the x plus 1 equals 5 to the power of x. So to do that, we're going to want to use this property of equality for logarithmic equations. So I say let's just use for this case, let's just use the common logarithm, so log base 10 of x. So what is the solution to this equation? We're going to take the logarithm of both sides, the common logarithm. So log 3 to the x plus 1 equals log 5 to the x. So this gives us the same base on both sides. And then we'll use the properties of exponents. So this would be x plus 1. So this comes down, and this will come down in front. So it's x plus 1 log of 3 equals x log of 5. Properties of logarithms again. So this is actually not even a property of logarithm. This is just distributing. So log of 3 times 1 is log of 3. Log of 3 times x is x log 3 equals x log 5. So I have log of 3 plus x log 3 equals x log 5. So I'm going to subtract x log 3 from both sides. Now I cannot just do 5 minus 3 and say, oh, that's 2. It's not the way this works. I could do log of 3 equals x log of 5 minus x log of 3. I have to keep them separate. I'm going to now log of 3 equals, I'm going to factor out an x from these two. So from x log 5 and x log 3, I'm pulling out an x. So what's left is log of 5 minus log of 3. Divide everything by log of 5 minus log of 3 on the right, and then do the same thing on the left to get x by itself. These go away, and I'm left with log of 3 divided by log of 5 minus log of 3, and that's equal to x. So if you plug this in your calculator, this would be approximately 2.15 for x. So that's how you solve an equation using the property of equality for logarithmic functions. And that does it for this section 7.6. So if you have any questions, please write them down, bring them with you, and I'll be happy to answer them.